You want to determine if Quinfinity Corporation stock is as volatile as TMI International stock. To do this, you collect a random sample of prices for both stocks. We have 41 random Quinfinity stock prices. The standard deviation was 5.78. Remember, we have to square that. We have 33 random TMI stock prices, and that standard deviation was 2.53, and we have to square that. If the Quinfinity stock is as volatile as TMI's, then the variances on these two time series should be equal. So the null hypothesis here is the variances are equal to each other. The alternative hypothesis is the variances are not equal to each other. Because the alternative hypothesis suggests that this is a two-tailed test, then we have to enter the upper critical value in this right answer blank and unnecessary in the left answer blank. And the reason for that is because for an F test, population 1 is determined by when the two sample variances are compared. Population 1 is always corresponds to the larger sample standard deviation. Since the largest sample standard deviation is 5.78, then that corresponds to Quinfinity stock price. The sample variance, this squared, for Quinfinity stock price will be put in the numerator of the F statistic. And the square of this will be put in the denominator of the F statistic. So now we need to find the upper critical value of this test. So I'm going to copy this stuff and paste it into Excel. The F-stat is the ratio of two sample variances, and it is defined to be, the ratio of the bigger sample variance divided by the smaller sample variance. So population 1 here is going to have a sample variance of 5.78 because it's bigger than the sample variance of the TMI stock price. The 41 stocks were used to compute the sample variance, or sample standard deviation 5.78. The 33 TMI stocks were used to compute the standard deviation of the TMI stock price. The degrees of freedom for population 1 is 41 minus 1. The degrees of freedom for population 2 is 33 minus 1. The sample variance is the square of the standard deviation. So we'll repeat that again. Now, this 33.4084 is larger than that sample variance. This value goes in the numerator of the F statistic, which means the 40 here is the numerator degrees of freedom. So the denominator degrees of freedom is 32 because this sample variance goes in the denominator of the F statistic. The significance level is 2%, and notice it's a two-tailed test, so we have to divide the alpha by 2. To get the upper critical value of the test, we have to go to row 0.01 and 32. Here's the F table. Row 32 There is no row 32. Suppose it was row 30. If there is no row, maybe we'll go to the closest one, say 30. Our alpha divided by 2 is 0.01. We would go over here until we got to column 40, right? So our critical value would be about 2.3. I don't want to be close. I want to be exact. So if you go to my website, my teaching website, and you click on F distribution calculator, 40 numerator degrees of freedom and 32 denominator degrees of freedom. This area in the upper tail is 0.01. So my F critical value is 2.523. And we only need 2 decimals, so I'm going to lop off the 3 and the 2. There is a lower critical value, but because we define F stat as the ratio of the big variance divided by the small variance, F stat can't be less than 1. So there's no point in getting this lower critical value. Now the F stat is pretty simple. It's just the ratio of the big variance divided by the small variance. And I'm going to copy that and I'm going to paste that into Cengage now. Right here. We only need 3 decimal places, so I'm going to chop off the 3. Now, going back up to part B, lower tail F tests are not performed because the population with the largest sample variance is placed in the numerator of the test statistic. It is unnecessary to find a lower critical value for two-tail F test because the test statistic is by definition larger than 1. Okay, so what have we got here so far? The test statistic is greater than 2.25. So the test statistic is not in between our critical values. And because it's not in between our critical values, the difference between the two variances is not insignificant. In other words, there's a significant difference in the two variances, which means we're going to reject the null. The null can be rejected at 2% significance. I'm going to check my work to make sure everything's good to go. And we got all the answers that we've answered correct. So, what is the data telling us? The data is telling us that Quinn Infinity has a larger variance in its stock price. So there's more ups and downs in Quinn Infinity stock price than in the TMI stock price. So if there's more ups and downs in Quinn Infinity stock price, then its stock's price is more volatile than TMI stock. And I'll double check my answers. And we should have them all correct.